This video is on solving quadratic equations by using the quadratic formula. We have in previous videos derived the quadratic formula and talked about the discriminant. This is the quadratic formula that we have previously derived. This is said as x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It is important that we understand it is x equals because you are finding the x-intercepts, the roots, solutions, and the zeros of the quadratic equation. It is all over 2a because all of this is being divided by 2a instead of just individual parts. So when we're going to solve by the quadratic formula, our quadratic equation must be equal to 0 because we have to make sure we have it in standard form. So we got to get our equation into standard form. We have to figure out what our a, b, and c values are, and we're going to plug them into the quadratic equation because these are all a, b's, and c's. We're not going to have any letters inside of the quadratic formula except for this one x. Then once we plug it in, we're going to simplify them if it's possible. So hopefully we can take the square roots of the values and we'll get rational answers. We can also look at our discriminant to determine how many solutions we're going to have and what type we're going to have before we even begin. So let's go to our first example. We have x squared minus 8x plus 15 is equal to 0. This is in standard form. We have x squared, x constant equal to 0. That means we can determine our a, b, and c. So our a value is equal to the 1 that's in front of the x squared. Our b value is the negative 8 that's attached to the x. And our c value is that positive 15 that is our constant. So now we're going to plug it into the quadratic formula. So what I'm going to do actually first is wherever I see a letter, I'm actually going to put parentheses and then I'm going to plug in my numbers. That just makes sure that I'm using the parentheses correctly. So I'm going to have x equals, because that is the only place we're going to have a letter is it's the x equals. Negative b, so I'm going to put parentheses, plus or minus the square root of b, so I'm going to put parentheses, squared, minus 4a, so I'm going to put parentheses, c, I'm going to put parentheses. Then it's all over. Notice I do not put it under the x because x has to be completely alone. This division symbol it goes from the negative of the beginning all the way to the end of the radical. Then the denominator is all over. It's 2, and then it's a, so I have parentheses. Now what I do is I take my a, b, and c and plug it into the spots where they belong. So my first parenthesis is that b value, so I have to put in that negative 8 inside of here. The next parenthesis is the b, so I put this negative 8 inside of here. The next one is a, so I have to put the 1 inside of this one. Then the next is c, so I put the 15 inside of this parenthesis. And then the next one is the a, so again I put the 1 inside of this parenthesis. Now, these two parts we can automatically fix on without a calculator, but what I'm going to do is I'm going to figure out the discriminant value right away. So I'm going to go ahead and put my x equals, I have a negative times negative 8 is a positive 8, plus or minus the square root of, it'll be our discriminant, so I'm going to figure that out in the calculator. And this is all over 2 times 1 is 2. So I'm going to go figure out the discriminant using my calculator. So I'm going to turn my calculator on. And what I'm going to do is I'm literally going to type in the discriminant, the radicand, exactly as I see it. So notice that it has parentheses, negative 8, close parentheses, squared, minus 4, parentheses, 1, close parentheses, parentheses, 15, close parentheses. This is my discriminant value. This is equal to a 4. Now if I come back up to the discriminant, this is a positive, so now I'm looking at one of these two. 4 is a perfect square. So I'm going to have two solutions. So I'm going to have x equals and x equals. They're going to be real, so that means there will be no I, and they will be rational. That means I'm going to have actual values. I'm no longer going to have a square root inside of my answer. That means I can simplify my answer. So my discriminant is 4. So when I put this into my square root symbol, I'm going to put the 4 in here. So that means I can simplify this completely and get out two separate answers. So I'm going to simplify this. So I have, just going to draw an arrow. This goes to the next part. So I'm going to keep the 8 right now, 8 plus or minus. I'm going to keep the all over 2 as well, because the square root of 4 will simplify. The square root of 4 is 2. So now I have all numbers, all whole, rational, nice, clean numbers, so I have to simplify this. So I'm going to have x equals 8 plus 2 is 10, divided by 2 is 5. Then I'm going to have 8 minus 2 is 6, divided by 2 is 3. So x equals 5 and x equals 3. We have two solutions. They are real. They do not have the imaginary on it. And they are rational. These are whole numbers. These are nice, clean, whole numbers. These are our two solutions. X equals 5 and x equals 3. Because the discriminant was a positive perfect square, I knew that I was going to have two real rational solutions, and we do. That means that it will cross through the x-axis at 5 and 3. On this next example, again, we're going to do these two examples here. Using the quadratic formula, we have to get this set equal to 0, so we have to have it in standard form. We have 8x squared minus 2x equals 5. This is not in standard form. We need to put this back in standard form. Our 8x squared is positive, so we have 8x squared is our quadratic term. Then we need our bx, which is negative 2x. Then we need our constant, which we need to subtract the 5 over, and then set it equal to 0. Now we have it in standard form, so now we can figure out our a, b, and c. Our a value is the positive 8, and you want to make your a value equal to a positive so it's much easier to deal with. The b value is the negative 2, and the c value is now the negative 5. Again, it has to be in standard form, so you have your a, b, and c. So I'm going to do the same thing I just did. I'm going to write out my quadratic formula, and I'm going to put parentheses, and then I'm going to fill in the parentheses. So I have x equals negative parentheses plus or minus the square root of parentheses squared minus 4 parentheses, 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 parentheses. All of this is over. Again, I did not extend it to my x, to then parentheses, parentheses. Again, this is the b, b, a, c, a, because I'm just following my quadratic formula. So I'm going to plug in my numbers. It's negative, then our b value was that negative 2. Then the next one is, again, a b, so I'm going to plug in that negative 2. The next one is the a, I'm going to plug in that positive 8. The next one is the c, I'm going to plug in that negative 5. And then the last one is the a, I'm going to plug in that positive 8 again. Again, these two parts we can do automatically, but then we want to get our discriminant to determine how many solutions we're going to have. So we're going to have x equals, it'll be a negative times negative 2 is a positive 2, plus or minus the square root, we're going to figure out a discriminant in just a moment, all over 2 times 8 is 16. So let's determine our discriminant. So our discriminant, again, is the radicand of our quadratic formula. So I have parentheses, negative 2 parentheses squared minus 4 parentheses 8 close parentheses open parentheses negative 5 close parentheses. This is equal to 164. Now, this is a positive, but is it a perfect square? So let's check. If I take the square root of 164, it is not a perfect square. So I know that I will be able to hopefully simplify this, but not to be two rational answers. I will probably still have a square root symbol inside of our answer, which you will have a square root symbol inside of your answer still. So we have 164 in here. So what we want to do is simplify this. So we have 2 plus or minus, and we still have all over the 16. Now we want to simplify the square root of 164. So to simplify that, we take that 164 and we divide by our perfect squares. So the first perfect square we can divide by is 144. Does not work. 164 divided by 121. 164 divided by 100, which we knew would not work. 164 divided by 81. 164 divided by 64. 164 divided by 49. 164 divided by 36. 164 divided by 25. 164 divided by 16. 164 divided by 9. 164 divided by 4. So 4 does work. So we know that it will be 4 and 41. So the thing is, it's the square root of 4 and the square root of 41. So this is really, when you take square root of 4, it's 2. Square root of 41 stays the square root of 41. So we're going to have 2, then the square root of 41. So we're going to keep the square root of 41 in our answer no matter what. So when we look at this, since it has a radical left in it, we want to keep it as one solution set combined. We're still going to have two answers, but we do not have to separate them. You do still need to simplify. So what I'm going to do is I'm going to separate these as two different fractions just so that we can simplify them. Because we're adding and subtracting fractions, you can separate them as two different fractions. They just have the same denominator. So this is 2 over 16 plus or minus 2 square root of 41 over 16. Because if I were to go back into the green, these both have the same denominator, so I can combine my numerators. And my numerators would combine to be the exact same as what I have in the green. So now I can simplify as much as possible. 2 over 16 is 1 over 8 plus or minus. 2 over 16 is 1 over 8 as well. But please remember to keep the square root of 41. That cannot simplify any further. That has to stay in your numerator. So this is really 1 square root of 41 over 8. Now, once we have each individual fraction simplified, we look to see, can we combine them back into one set? Since these have the same denominator again, we can combine them back into one answer. So x equals, it's going to be all over 8. This will be 1 plus or minus 1 square root of 41. Now, if you don't have to put this 1 attached to the square root of 41 because it's already there, but it is perfectly fine to do that. You must put this 1, however. So we do have two solutions. We still have 1 plus the square root of 41 all over 8, and we have 1 minus the square root of 41 all over 8. So we can just write it as one answer, as x equals 1 plus or minus the square root of 41 all over 8. And again, these, we still have two answers, but they are irrational, just like what our discriminant said was going to happen.